Welcome back. Today we're going to start our project on volume. And where we're going to end is you're going to pick one of these projects, either project 1, where it's having you compare the volume of different glasses and tell us which one holds the most and how much does it hold. Number 2, where an object is placed into equal cylinders, and we want to know which one will have more water left in it, meaning displaces less water. And then the third project, which is kind of like a mishmash of everything. If you want a little bit of a challenge, this would be the one to pick. They're all challenging in their own right, but this one goes back a few units because it doesn't, and this is the common theme that we're getting at in the launch, is there's no height. You have to use your prior knowledge and what's given in the picture to figure out that height. So number 2 will tell you the height. Boom. But in number 1, project 1, yep, height, but this is not the height. Okay? And we're trying to prepare you for this project, specifically for project 1, because it's typically what people choose. It's the first one they see, so that's what they go with. So that's this problem number 2. If you can do number 2, then that means you're ready to do glass number 3. All right, so problem number 2 teaches you this. Okay, teaches you how to actually get the height. So let's just start. It looks like these problems are identical, but they're not. This 13 is placed differently. So I would say you do number 1. When you're done, check your answer and then come back and we'll do number 2 together. All right, so let's do number 1. Determine the compound volume. Well, I see 2 shapes. I see the volume of a cone, which is radius squared pi and height. And then the other object I see is the volume of a cylinder, which is radius, this one's divided by 3, because it's got a pointy top. And then the cylinder, I realized, is the radius squared pi and height. Okay, so let's start filling this in. The radius is going to be the same for both shapes because, it's just contained in both shapes. So my radius is going to be 2, and then we'll do the cylinder. So this would be 2 squared pi, and then the height of the cylinder is 2. So this is 4 pi 8, 4 pi 2, which is 8 pi, which is approximately, let's see, clear that, 8 pi. 25, we'll call it. I just want a round number. 25. All right, now for the cone, let me move this math out of the way. Let's do the cone. Well, as we already figured out, the cone has a radius of 2. The height, right? This is the important part. The height, which makes the right angle, it's in the middle, it goes straight up and down. That's 13. All right, and then we won't forget to divide by 3. So I'm just going to type that into the calculator. 2 squared pi 13, then divide by 3. So 5450, we'll call it. 54.5. And I'm looking at the picture, and since the objects are separate from one another, it's not like one is contained within the other. They're not overlapping. This is an add. This is an add. So we are just going to add these numbers together, and we'll get the volume of the total equals 79.5. right? Bring down the 0.5. 5 and 4 gives me 9, and 2 and 5 gives me 7. Okay, great. So that's the straightforward one. We talked about adding. Project number 2 is the opposite of this. This is where the two solids are overlapping. You're going to have one bigger solid and then a second solid inside of it. There's my sphere. So it's like, what do you do here? And I'll let you kind of figure that out. And we'll be in the Zoom if you want to ask us a question about project number 2. But let's finish up with our launch. So here, what they're saying is 13 is what we call the slant height. It's not the vertical height. It's not the actual height. Okay, this is what we want. So this problem is different. This cylinder, we already figured out, right? It still has a height of 2, and it still has a... Oh, I lied. I messed this up. Darn. Okay, well, I guess we redo this one. No, let's pretend that I messed this up. The radius is not... No, we'll do it again. The radius is not 5. These answers are not correct. But that's fine. You know, we'll just persist. Let's see. The radius is actually 5. So this should be 5 squared. This should be 5 squared, making this 25, making this 50 pi. And then when we go to do, let's do the calculation now. So 50 pi gives me 157. And then in the other one, we'll have 5 squared pi 13 divide 3. Yeah, so 340 we'll call it. And then we're adding. So 340 and 157. 497. So if you got something around 497, that's the volume of the total. And the reason why I kind of like redid this one, well, one, it's wrong, but two, this cylinder volume is the same in both pictures. It has a height of 2 and it has a radius of 5. So that's not going to change anything. So I'm just going to carry that calculation down here. The volume of the cylinder is 157. Now what will change, and this is where you want to kind of zone in, this is what you'll have to do. You're going to have to figure out the length of this blue piece. So let me separate this. I'm going to notice that this green piece is 5. This blue piece here is what we're looking for, so I'll call it X. And then this red piece, the diagonal, or the slant, or the hypotenuse, there's the throwback, is 13. Now, if I knew the angle, right, I could do trig, but I don't know the angle. So this is a Pythagorean theorem. And this is where it's the leg, let me do it this way. Leg squared plus leg squared equals hypotenuse squared. So this is leg squared plus leg squared equals the hypotenuse squared. This would be 5 squared plus x squared equals 13 squared. 5 squared is 25. X squared is still x squared. 13 squared is something big. 169. Okay, what am I solving for? I'm solving for x. I need to get rid of the thing that's bothering x. Yeah, the square is, but that 25 is bothering it first. I want it to look like x squared equals. So how do I get rid of plus 25? I subtract. Whatever I do to one side, you do to the other. Oops. So now I'm going to bring down the x squared. I'm going to bring down the result of 169, take away 25. We get 144. And now I ask myself the same question. What am I solving for? I am solving for x. What is bothering x? The square. How do I undo squaring? What's the opposite of squaring? Well, the inverse operation is right above it, square rooting. So if I want to get rid of a square, the thing I do is square root. They will cancel. Whatever I do to one side, you do to the other. I have x, and then whatever the square root of 144, that will be my height. I think it's 12. So now I can see that the height is actually 12. So I come back here and I go, okay, well, when I go to do my volume calculation for the cone, it's still the same formula, radius squared, pi, height, and divide by 3. But the height will be different than the other one. The height is now 12. So I'll have 5 squared, because that's my radius, pi times 12 all over 3, which equals 314. And then we're going to add on that 157 because we want the volume of everything, the compound. So in total, we get about 471. The volume of the total is 471 because we are adding up this and that 314. Sweet. So that's basically, prep for project number 1, particularly that third glass. The first 2 glasses aren't too bad. Break them down into their pieces. Today, you're going to look at all of the projects, kind of get a feel for them, which one looks more interesting to you, which one you want to work on, and then you're going to pick that project. Leave us a comment, okay? And do some work on it. We will be spending the rest of the week, Thursday and Friday, so today, Thursday and Friday, completing these projects. So I would encourage you, do the launches, figure out what's going on, decide which project you want, and then do some work on it. Try and work it out. Be ready to come to the Zoom tomorrow with some questions. In tomorrow's Zoom, you should really finish up the math. You should have it done. And then on Friday, you're going to work on polishing it, making a graphic, whether it's on paper or designing something in on your computer, and then presenting kind of the project, the work that you'll submit. So thank you so much, and we'll see you in the Zoom.